talking about section 2, where we're looking at, we did special angle relationships, and we ended with writing down that the angles in a triangle always add up to what? 180 degrees. So here's a question relating to that. The measures of two angles in a triangle are 33 degrees, 12 minutes, and 26 degrees, 34 minutes. Find the measure of the third. So what would I do? Add those.
180. Or add them. Yeah, it's okay.
So remember, when we add these, we add the minutes together, so 12 plus 34. And we add the degrees, 33 plus 26. So we get 59 degrees, 46 minutes. And so then we have to subtract that from 180. So this is a good review from last week. What do we have to do here? We have to say 180 degrees is like 180 degrees and 0 minutes. So we have to borrow a degree. And if we bring over a degree, how many minutes does that carry over?
60.
So 60 minus 46. And 179 minus 59. So we get 120 degrees, 14 minutes. Is that okay with everyone? Relating to triangles, a couple other things that we need to talk about. Classifying triangles, remember you can classify them based on angles and sides. So what does it mean if I say we have an acute triangle?
Less than 9.
If it's acute, all angles are less than 90 degrees. What about a right triangle?
190 degrees.
What about an obtuse triangle?
One angle of 90 degrees.
Why can't it be two angles bigger than or bigger than 90 degrees? Right, we know it has to add up to 180, so you can't have two right angles, and that would make the third angle 0. Or if you had two angles bigger than 90, your third one would be negative. That's not possible. All right, we can also classify triangles based on sides. What does equilateral mean?
All sides are equal.
Isosceles? And scaling. What am I talking about when I say similar triangles? So similar triangles are triangles where their angles have the same measure and their sides are proportional. So if I took two triangles like this, these are both triangles with the same angles, 30, 60, and 90. If I put measurements on these, and this is just made up, not to scale or anything. If I said that this side was 10, could you tell me what these other sides were? How did I get 5 and turn it into 10? I multiplied by 2. So all the sides, if they're similar, you would have to do the same thing to all of them. So when I say they're proportional, it means essentially you multiply by the same thing to get the new triangle. Similar triangles, sides are proportional, angles are equal. Let's look at except I don't want to give you guys the picture. Let's do it without the picture. Let's say, I'm going to give you this. Let's say triangles DEF and GHI are similar. I want to find the measures of G and I if the measure of angle E is 34 degrees. Okay. So when I'm drawing similar triangles, I did not give you any information about their sides. So all I could do is draw a rough sketch. Any triangle is fine because I don't know much about it. I have triangle DEF and I have triangle GHI. When I'm listing similar triangles, the order is important. So when it says D is first in this triangle and G is first and same, that means D and G have to have the same measurement. Okay, so then we know that E and H would have to be the same measure, and F and I would have to be the same measure. So it told me that angle E was 34 degrees and angle I is 85 degrees. All right. So I need let's make this, sorry, I had changed this problem and then my computer crashed again, so I lost my changes to it. Let's find the measures of angles G and H. Which one's easiest to find? H. It has to be the same as E, so H would have to be 34 degrees. What's angle F? I didn't ask for it, but 85. How would I find D and G? Mm-hmm. 119 degrees, or 180 minus 119 is 60. Okay, so if you're looking for a missing angle, you just have to remember which angles are the same. Let's solve for something involving a side. So I'm going to give you a picture this time. I'm telling you that these are similar triangles. We have to find the lengths of the unknown sides. Just as a notation, in triangles typically we use capital letters for the angles and lowercase letters for the sides. Since this is angle R, the side across from that would be side R, but lowercase. So this would be side Q. That's a notation that we will use all year, or all semester, I guess, with the sides being lowercase, and it's just across from its angle. All right. Do you have any idea how we would go about finding the sides? They're not just equal like the angles are, but what did I tell you about the sides? They're proportional. How do you set up a proportion? What's a proportion? What's it look like? It's like a fraction equals a fraction. Okay, so let's say I want to find R. There are different ways you can set this up, but I'm just going to focus on this triangle for a minute. So I need side R. The side I know is 12. You have to pick the same sides in the same order from the other triangles. So R was the bottom, so the bottom over here is 10. 12 was my height over here is 8. So R over 12 equals 10 over 8. Then how do you solve a proportion? Mm-hmm. So 8R equals 120. And side R is 15. So to find Q, we have to do the same thing. Tell me a proportion that I could use. Q over 12 equals what? Mm-hmm. Q is this diagonal side, so the diagonal side over here is 12. 12 is my vertical, so that's my 8. So I get 8Q equals 144, and Q is 18. Questions there? I want you guys to read this problem and see if you can set it up. But again, I'm going to take away your picture. You can draw one. We're trying to find the height of a tree. So that would be, can we all agree that we're going to go straight up for that? We're going to assume it's a nice straight tree. I don't know that height, so I'll call that X. Okay, one of the most common questions Because I can about promise you that I will put something with a shadow when it comes time for a test or a quiz. And probably 30% of people always miss it. Where does a shadow go? On the ground. People label it as a diagonal all the time. So a shadow is on the ground. So that would be my 38 feet. So there's one triangle. All right, then I have a person. So we're going to assume he is standing up. He is 63 inches tall. And his shadow, so that goes on the ground, is 42. It is not an issue that these units don't match because both of these are feet and both of these are inches. So as long as you don't have different units in the same triangle, it's okay. So we can just set up a proportion. What would I write? X over 63 would work, equals 38 over 42. There are different ways of setting it up. You might have said like x over 38 equals 63 over 42. As long as they're corresponding pieces, that's fine. So you hit 42x equals so we get the tree is 57 feet tall. Questions on any of that? Then I want to give you guys time to work.